We will understand the logistic regression, right? Basically, the logistic regression is the first understand. So, logistic regression is a classification problem, right? This is basically a classification problem. Classification problem. In a classification problem, we will do some. We will apply. Basically, we not using the logistic regression. We simply apply the linear regression, right? Linear regression. So what is the problem we are facing in a linear regression? And that is, but basically we are understanding the use cases, and why we not using the linear regression? What is the problem we are facing? So understanding this in this video, right? So first we are going with the what is a logistic regression? Okay. So let's get started and we with example. We have data set, right? We have data set. That's the study R, and second one is the let's pass and fail. Okay, we have data set and simply we have two are study 3, 4, 5, 6 and 7. And similarly, if some students are studying for 2 hours, they got a fail. Okay. Similarly, with study for 3 hours, they also fail. 4 hours, that guy also fail. 5 hours, someone, in study, in student study for 5 hours, they basically go to pass. Okay. Similarly, for 6 hours and as well as 7 hours and go forward, so they basically pass. Okay. So this is a basically a classification problem, and this is a binary classification. Okay. Binary classification. uh, Binary classification. So try to understand that one thing in a binary classification. When you draw, okay, understand the graph. That's the most and basically you understand far better with graph. Okay, so that's the we have graph. Okay, and in a logistic regression, what happening there basically is a one and zero. There is the input and output, right? And someone is a midpoint, basically is a 0.5. And let's consider we have data point 0, 1, 2, 3, 4, 4, 5, 6, and that is 7. And this is basically study R, and this is the pass or fail. Okay, pass or fail, pass or fail. So in that case, let's begin. Okay, zero basically okay. So zero basically is a fail, and one is a pass. Okay, so in that particular case, let's when we study for 1 hour, so this fail. Okay, 1 hour fail, 2 hours study also fail, 3 hours also fail, and 5 hours study some student they got a fail. Okay, but when students are study for 5 hours, they basically pass. So that's a plot somewhere. 6 hours also bottom, 7 hours also pass. Okay, so in that case, let's that's the one, and this is a line. Okay, so in that case, when basically the output is a greater than 0.5 or equal to this is basically a pass, right? Or basically this value is a 1. Okay, and similarly the output is uh, less than 0.5, right? So that's considered as a failure output are a 0. So that simple concept we will learn. Okay, so in that case, when we draw discrete line, so is a discrete line is look like that. Okay, so this is the basically a discrete line, and you draw that line. So this is the 0.5, it's been your path. Okay, but problem is what happening when the and basically the less than Less than 0.5, this is a fail. Okay, and this is basically, and that particular curve, let's say any value in between, they basically a fail. Okay, and this other is a pass. So problem is, okay, that's we drawing a graph and that simple concept we solve, that's no problem. But problem we are facing when we came our outliers. So that is a 7 hours, okay, okay. But problem is some students are studying for 12 hours, right? This is the outlier. So what happening in that particular case? That basic line is squeezing something like that toward the outlier, okay? Toward the outlier. And that particular case, you will see the dataset said when said when you study for 5 hours, you become a pass. But in a graph or basically your model, you train your model. So there is a value of high you have is to take 5 hours, so you got a fail, right? And someone is is tweeted line. So in a 6 hour, you got a pass. This is basically a problem is squeezing of line. Okay, squeezing of line. Squeezing of line. So for that, what we will do and understanding what happening here. So we need that type of line. They basically not squeeze or basically the dot based line uh, jump that just like that, right? They basically at that particular point squeezing and that point, right? Squeezing. And in a logistic regression, basically the output are also between the 0 to 1. Okay, so there's a out given king's outlier. So is a more than one, right? And basically less than zero. That's not a good model, or just that's not a good because it's a so basically the above the one. And in logistic regression output is comes between the 0 to 1. So for that reason, we some give a many we apply a equation function that will help us to skew the line, right? This line is came here. So in that particular point, there is skewed something like that toward the outlier, right? So that is the logistic regression, and that's why we are not use the linear regression. Basically that's for skewing the best fit line. Okay, best fit line. So a summary of that class, we understanding one concept is a outlier. Okay. So outlier come outlier came, then the base fit line, and the base fit line not work well, right? The base fit line is basically skewed toward the outlier. Outlier. That's the only reason that we can't use the logistic, linear regression, simple linear regression, multiple linear regression, right? And second point is it's the output, right? Basically, the output is a greater than 1 and less than 0, right? Basically the output is greater than 1 and less than 0. That's the two reason behind it. We can't use a linear regression instead of a logistic regression, right? So this is for today's video, and we will understanding all of this concept of logistic regression in a next video.